derive this. Notice the x's and the y's, so we have to use implicit. How do we derive implicitly? If you want to use the correct terminology, you probably should write something like this first, but as I said yesterday, most people do skip this step, but yes, we're going to derive it with respect to x. No, it won't be, Mark.
Not like induction, where you have to like...
But you might see that terminology somewhere in the exam, just don't be scared by it. Derive it with respect to x. In other words, y is a function of x, so you can imagine y being a function of x. Okay, so we did that yesterday. So the derivative to x squared is still just 2x. The only thing that's a little bit unusual is the derivative of this y function cubed, which you use the chain rule. So it'll be 3y squared multiplied down by the 3. But then you need to, if this was a function, you would multiply afterwards by the derivative using the chain rule, wouldn't you? And that would equal then, what's the derivative of a constant? 0, yes. So then what do we do to get the derivative? We must isolate the change in y over the change in x, so subtract the 2x over here and then divide down by this. Divide both sides by it, and we get this. Okay. Now, yeah, so this is going to look like, it's not going to be an ellipse or a circle. Well, let's imagine it's an ellipse. It's possible. That might be what it is. The problem here is to get the slope or gradient at any particular point, we need both the x and the y point. You see that? We can't just sub in this x value. Well, we can, but we still won't get the gradient. We need the x and the y point to find out what the gradient is going to be. Because an x and a y is equal to the gradient. So how do we overcome that? Well, we look at, I need to find the corresponding y value for this before I can do it. So I go back to the original function, which I kind of just drawn here. I got to substitute in. So I have 2 squared plus y cubed is equal to 5. So I'm looking to find this y to match this point. I haven't got the full point here. So 2 squared is 4 plus y cubed is equal to 5. Subtract the 4 over, we get y cubed is equal to 1. That's convenient because we can get the cube root of that. Y is definitely 1. Is it plus or minus?
It's plus.
Yeah, it's got to be the sign for cubing. Yeah, it won't do the plus minus thing. So now we got 2 and 1 is our point to sub in to our gradient. So our gradient would be minus 2 times 2 all over 3 times 1 squared, which is minus 4 over 3, and that is our gradient.
Great.
Fantastic. So that's the gradient tangent. You didn't need to go on, but you could find the actual tangent line at that point, but they didn't ask for that. Okay. Do you feel ready to do a few?
Yeah, what's the actual tangent line?
If you need to find the tangent line, you could just use this formula. So you get a point. We have a point here. And now we have the gradient here, which is minus 4 over 3. Okay? So you just sub into that, and that gives you the line. You've seen this formula before?